Okay, so I just have to go over some basics first of all. Let's see if this pops up. Games. Nope. Unreal training. Just got a little script I've got to read out first. Apologies. A warranty? No, it's not a warranty. You get no warranty with this.
I feel we are not liable for any inconceived creations you come up with in the next 6 months after this call.
Okay. So just to introduce myself, I'm Dan Baird, Director at Infinity 27, and I'm doing training for Unreal Authorised Instructor. The topic we'll be teaching today is Blueprint Communication, and the average level of the learners is beginner. Just to double check, I've received recording permission from each learner prior to the training session. If you guys just want to introduce yourself, just your name, and that you've been told it'll be recorded.
I'm Quinn, and yeah, it's fine. I'm Daniel, and yeah, that's fine as well. I am Scott, and it's fine with me.
Excellent. And just to confirm, we have 4 learners today. There we go. Okay, so Blueprint Communications is the topic for today. So you guys have already done the basics of blueprints using Unreal Online Learning. And one of the challenges you've faced is communicating between 2 blueprints. So getting one blueprint to control another blueprint or access another blueprint's functions and variables. So for this session this morning, what we're going to do is look at one-to-one kind of direct communication with blueprints and a way to do many-to-one communication via actor casting. I'll explain a little bit later why I consider it many-to-one because that seems to be the correct way to use it. And tomorrow we'll be doing event dispatchers and blueprint interfaces, which are more advanced ways to communicate. Okay. So we're going to start from the very start. The reason that I'm going to teach it this way is that basically I feel like it's very easy to follow a tutorial, just point and click, follow the person along. But for the sake of actually learning and memorizing and understanding how you should learn, it's very important that kind of I show you my process about how I go through this. So basically how I learn from different sources as well. Okay, so what we'll be doing today is we'll be learning using an example project. So we're in the launcher here. We just go to the Learn tab, and we can scroll down and click for Content Examples. Content Examples is an oldie but goodie, as you can see. It's been supported for quite a long time, and it's got different things inside here. These type of galleries are what we'll be looking at today. Blueprints are included in this here. Okay, so I've already downloaded this. We go to the library, and once we've created the project, we can add it here, and that's going to load up. That's going to load up on my second screen first of all, so switch those over. Everyone has previous experience with going to the marketplace, pressing to download or create a project, adding it to their existing project. Okay. So these content examples, a lot of people overlook them, but they are some of the best content out there. 1, because they come directly from the source, and 2, because they're programmed by people at Epic Games Unreal Engine. Okay, so what do you have in these scenes? Basically, we have an overview scene here, an example project welcome. And this is set up so it's like a game and also something you can deconstruct. Okay, so you see there's these different things which we'll go through in a minute, and then there's a door on the other side that opens up depending on how many examples there are inside each level. Okay, So first of all, we're going to look at this demo scenario. So press play. I can move around just like a normal first-person shooter game, for example. It says here about opening maps and levels. We'll come back to that in a moment. One of the very first things you'll see is there's the demo stand, which basically shows example content for a static mesh. So one example, another example. If I hit escape here, what I can do is I can click this and I can see there's an object in the world outliner. So this exists in the level. It is essentially being drag dropped from here, from one of these folders into the viewport here. And we've got another example here. This one's a bit more advanced. You may have noticed that the color of the rocket was different in play. Okay, that's something that will get you to deconstruct later and find out how that's done. Basically, those are static meshes, so those are things that will stay still during gameplay. They will not be animated. Okay, anything that will be animated will be a skeletal mesh, generally. However, you may have things like this. We can actually play, or we can use the drop down and simulate if I don't want to actually take control of the character and I just want to be a free moving camera. And you'll see this object, it's not actually a skeletal mesh, it is a static mesh, but it is being manipulated through blueprint code. And we can see here that there is a blueprint drive in this. Okay, now we're just going to crack this open to have a quick look. So there's a couple of ways to do this. I select the object, and one of my favorite ways is to just use the type over here in the world outliner, and I can open up which type of blueprint it is. Now, when you first open up blueprints, you might be a little bit afraid of like how much math there is here. As a designer, I'm not super hot on maths like a programmer would be, but I find that it's very simple once you actually take the time to step through each thing individually, and yeah, it can be less daunting. So we'll open up the blueprint. We'll see that we have a couple of things here. We have the event graph, which is the main set of nodes. So each of these is a node that controls some kind of logic in here, events, things that will happen. And we also have a timeline, okay, which is this object here. We can double click, or we can go across here at the top. And what this is just some basically data that will drive or can be used to drive some animation, for example. We can see that we've got an impact here, we've got a movement, and we've got a scale. So all of these are curves and that drive data between some value over time. Okay, so the value is in the y-axis and the time in the x-axis. Okay, so this one here, for example, the movement basically just shows let's say the ball's movement, because that's what it's plugged into, will kind of go down. It'll stop near the bottom for a second and then come back up. Okay, and then it'll loop on this timeline. Okay, so looks very intimidating, looks very complex, especially when it has all these plugins, inputs, but don't worry about that. Okay, we've also got construction script, which is nothing in there currently, and we've got the viewport. So this is how you move around inside of the blueprint generally. Okay, you'll notice down the left-hand side there are some components. Okay, so if we go into the viewport, I can click the ball, and there's the ball. Okay, it's a static mesh component, as I say, it's not a skeletal mesh. And then we have a base, which is just this entire scene, this empty scene here. Where is the central location? Okay. Now we'll close that one and we'll move along. So these are some interactive stands that we have. Basically, the blueprints that are presented here are a bit more complex. So we've actually got quite a lot of blueprints. If you're watching the right-hand side, everything I'm selecting is a blueprint. This slide is a blueprint. This blackboard is a blueprint. This object here is a blueprint. This button is a blueprint, etc., etc. Everything apart from the lights here, which are just basic spotlights. Okay, so as I say, this is the method I use for deconstructing the content examples. You want to go in, you want to hit play or simulate, you want to walk through it, you want to look at the code that drives the different objects. So if you think, oh, I need something like this in my game, where there's a button that drives this these triggerable gears, then you'll want to have a look at how the blueprints work. So I'll zip along here. Looks like I press stun on the button as the player, and it makes the cogs move. Okay, so you'll want to open up the blueprint and examine the functionality within. Okay, one of the ones I want to actually focus on is this button, just for now. So we open that up. Again, we've got a timeline that shows the button being pressed. So this is the depression of the button, and the glow, which kicks in after a fraction of a second, kind of increases the glow of the button. We'll notice inside this one we actually have a construction script. So we've got a dynamic material instance, which is basically a way for us to control the material as the game plays. We are assigning that to a variable. Okay, and we can basically, what I want to have a look at here really is the button setup and the hierarchy. So this one is a bit more complex. We have not just the base, so the scene itself. We've got the button base, which is this black object around the bottom, and we've also got the button inside. So if I select, say, the base, sorry, the button base, I can move this object, okay, inside there. I can also position this thing inside here, so I can move this, and if I move them, because this is a child, it's underneath the root of the button base, then they will move together. Okay, just Control Z my way back. We've also got this object, which is a trigger, which isn't parented here, it's parented to the base of the scene itself. Okay, that's why that wasn't moving around. And if we look down the right-hand side, which is generally when you click on objects inside of here, down the right-hand side is where you'll find all of the details for them. We can see we've got something down here called events. Okay, so not only do we have kind of location, rotation, scale, some other things in here, and to do with rendering or collision, we've got these events. So the events are kind of preset events that you can call in your blueprint to get some functionality. Okay, so if I just click on one of these, event, which is begin overlap, I can zip to that part of the event graph, and I can see the code that runs here when something overlaps. So we'll see here, there's some nice explanations about what it does. So the event fires when a pawn begins overlapping the trigger, and the pawn will be anything that a player controls, generally inside the scene. Okay. So not to dwell here too long, we'll have you guys come back to deconstruct these later as a nice little activity. If I zip along here, I can see there is the documentation actor. Now these are pretty much only inside the editor, and they are for us as developers. So what I do is, outside the play mode, I click on it, and on the right hand side I've got the details panel again, and I can see I can open help documentation, and what that will do is bring me to the documentation specific part of Unreal Engine. There we go, and there's how to use it and cross-reference with documentation. Okay, so now what we're going to do is we're going to zip back to this one, which is about opening maps and levels. There's a few different ways to do this. Okay, so I'm just going to cover a quick few ways just so you can choose a way that works for you. So we can go File and we can go Open Level. You'll see there's a whole bunch of levels in here because the Maps folder is highlighted. We can also use the content browser in the bottom here to open up the Maps folder, and we'll see the maps inside there. Double click one to enter it. There's another way to maneuver, which is to use the reset maps, which will appear here in a second once we've opened a map. So let's open up our Blueprint Communications map. We want to open up the map, the level, and not the map build data registry. Okay, and that's where the lighting and such is stored for each level. So I'm just going to click don't save. I don't want to save any of the things I've done inside there, because if I broke something, I don't want it to be broken when I go back to it. Okie dokie. So now I can see we switch to the Blueprint Communications level. Okay. I can quickly get back to my other level by going back down here. Now you'll see recent levels available. Blueprint Communication, because I've opened that. I can also add this to my favorites. So I'm going to add this Blueprint Communication to my favorites. This is on per project basis, so I can get back to here nice and easily. I can remove it, or I can just click here and it will reload the level. Nice and handy. I can also go back to my overview. Another way to find your maps is I can filter. I can use these filters here inside the content browser. I can just say I want all levels, and if I open this out, I can select under which folder. So if I look on a character folder with the levels filter on, no levels in there, so nothing shows. If I highlight maps, levels. If I highlight animations, no levels. If I highlight content, levels. And I can also just leave these filters here, so they're still available to select, and I can just turn them on and off as I see fit. So I'm going to go back to, I can also search, I believe it was called Overview. We'll click that, and I'm inside a different level now, which is an overview, so I got the name wrong there. But what I can do is I can now look at recent levels, and I can switch between them here, or I can just use favorite levels to load them. So I'll just go back to the Blueprint Communication level. Okie dokie. So just some tips on navigation there and moving around levels, because as projects get bigger, people tend to lose their way, is what I find. Okay, so now we're looking at Blueprint Communications proper. Okay, so inside this map is examples of Blueprint Communication. Now we're going to cover these first 4 sets in this session, and then we'll continue on to these other sets in the next session. Okay, so first of all, I'm just going to hit play. I'm going to move around, and I can see basic communication with a target blueprint. So this example features a button blueprint, this one here, the red button, that toggles a light blueprint, which is that light over there, on and off via a custom event. Approach the button while playing to activate it. Okay, so I move in, and there we go. Now I didn't press anything to get this to come on, so my question is, how does this actually work? And what I can see here, if I hit escape and go back to the editor, is that there's this volume here, this capsule volume. So if I click on my button, I can see that the capsule volume and the button are all one object. That's because they are a blueprint. So they, if I click there, I can click on the viewport and I can see all these objects together. So yes, we've got the triggerable collision, which has an event attached to it. And we'll have a look at that in a second. And then there's the button mesh itself. Okay, so I'm not actually pressing the button. Nothing's happening with that mesh. It is simply the trigger collision, which is invisible to the player, but as they walk up to it, it triggers. Okay. Now I want to see how this trigger is actually, what code this trigger is running, and how it's getting the light to come on. So I click here, and that takes me back to the event graph. I can also click here to get the event graph real quick. And then I'm just going to read the blueprint from the start node, which is the event. The red nodes are events. Okay, and I'm going to read through all of the comments, and I'm going to talk to myself about how this blueprint works. Okay, because it's very important that we don't just look at something and say, well, I understand that, and that one at the end. It's really important to understand the flow of the logic. Otherwise, you'll not be able to create your own blueprints very effectively if you don't understand what all these things do. Okay, so starting with this one, I'll just expand my screen out here so I've got a bit more view space. I can see it says here, the overlap event fires when a pawn touches a trigger, same as before. I can also hover over these nodes, and it gives me the instructions which are written by Unreal Engine team. So it gives me a full description to say that the event is called when something starts to overlap this component, the component being the trigger collision. For example, a player walking into the trigger. Some more information there as well. So these execution pins, these white pins are the flow of the logic. So we can see that when this fires, this pin will go down and connect here to this flip-flop node. Okay. If I hover over flip-flop, it just tells me that this is a node that will alternate between A and B outputs, starting with A. So that means that the first time this fires, it'll fire A. Next time this fires, it'll fire B. Okay, and what we can see actually is both the begin overlap and the end overlap are connected to this flip-flop. That means that when the player enters this volume, A is going to fire because that's the first time. And when the player leaves this volume, it's also going to trigger the flip-flop, and then B will fire. So what we can see is that we've got two routes essentially. Okay, we've got this top route and bottom route, A and B. So on the A route, we can see that we are set in the scalar parameter value. Okay, so change a scalar value in the button material, that turns it green. Okay, and then in this one, we are toggling the light. Now this one's a function. Okay, and this one is an event. We can tell by the little icons up here. So blue F function and this little arrow inside the the square is a function, an event. Okay, call a custom event in the target blueprint when it turns on. Okay, so how does this relate to communication? Basically, this is happening inside of this. So all of this is happening inside of this blueprint, okay, using standard Unreal Engine functions and nodes. However, this is a custom event, same here, okay, that basically turns a target light, the target is this target light, on and off, okay, so those are the variables. Now we can see over on the left hand side, we have the components as variables, okay, so I could drag on the trigger collision, I could do the same here, same thing, trigger collision, or I can get my, shrink the components, I can get my variables that have been made. Okay, so these are custom variables for this blueprint. There's a button light material, which is this one here, and we can see it's blank by default because it takes a material, which if we have a look at the construction script, is generated when this object is constructed, so when it is born essentially into the world. Okay, and then we have the target light here, okay, which is, if we have a look on the right hand side, a variable that is a BP light bulb basic. So this target light is exposed publicly, okay, so notice the closed eye here. This is not public, and it will not be editable in this instance. This one is public. What that generally means is, if we have a look over here, we have our BP generic button, and in here we actually have the details panel. We have the target light right here, okay, and it allows us to actually select a light from the level to fit, okay, as long as that light is of this blueprint type. Okay, BP light bulb basic, then it can be filtered in this list, so it exists inside this world right now. We can select it. We can also use the eyedropper here to just pick the light. Okay, if we hover over, notice that anything that's not one of these blueprints cannot be selected. We can select that there. And just to show you what public and private do out here, if I turn this to public, okay, so the button light material public, compiled, would see that, oh, now I can actually set this as well. But I don't want to do that because I don't want to be accessed. Okay, it's always best to only expose what is required to be edited and not the other way around. Don't expose everything. Okay, that can quickly lead you to trouble. So I've just changed that back. Okay, and now we're going to have a look at the direct reference inside of here. Okay, so how is this thing actually communicating? It's the target light, okay, right here. And basically what it's going to do is it's taking a reference from this one actor to this other actor. Okay, so now this actor here knows about this actor. Okay, so the button knows about the light bulb. What the button can now do, if we have a look inside of here, is it can access any of the variables or events inside of this blueprint, okay, inside of the light bulb. What does that mean? So I'll just double click this and you'll notice it opened up the blueprint light bulb basic, and we have the new a quick look here, viewport, we have the bulb itself, the new blueprint that we're referencing. Okay, it's got a couple of functions here. It's obviously got its construction script, and it's also got something for updating its the light color. Okay, we'll not dive into that too deeply, but we can see here inside the event graph, he has this toggle light event, and basically what someone has done to create that is they've just created a custom event. So they've went add custom event, my event name. Okay, and with the reference over here, they simply dragged it out and selected their event. Okay, so super powerful direct communication, this is called. So this is for one-to-one. Okay, one blueprint here inside the world is going to reference another one blueprint inside here through a direct reference. Okay, which we can expose and kind of make it nice and easy for us to pick the two blueprints inside the level. Okie dokie. Just switch back here. Just get rid of my event. It's very nice, but it's not needed. Now, again, how do we learn this? Let's just read this one left to right to see what this thing actually does. Okay, so we can understand how it's going to work. So it's going to toggle the light with flicker transition. So its custom event is going to fire. Okay, so as before, this thing runs left to right. It hits here. There's nothing after it, but it goes inside of here and it starts running this code. Okay, so it just checks, is the light being turned on or off by the Boolean? Yes, turn on this one, turn off on this one. So it fires. If it's true, then the light will flash. So this timeline plays from the start. And as it updates, okay, so each frame it updates, okay, across this timeline. I'll just double click that so we can see. So it should flicker with this kind of motion. It's going to update light color, so it's going to run this custom event here. Okay, again, I can click on there, or I can double click this to get access to it. Okay, so every frame it's going to run this. Okay, and basically what it's going to do is it's going to get the color, the intensity, and set these. Okay, and then what we can see is that if the player leaves this zone, again, the flip-flop will fire, and because it's in, we'll fire A, out will fire B, just by virtue of the setup here. We will then set the parameter value. In this one it's 1, in this one it's 0 of the button light material, and we'll toggle that light again to the off state. So this code will then run, and it's going to run through here. It's going to be false. It's going to come out to the sequence, which is quite interesting. What it's going to do is it's actually going to interrupt the timeline, so it needs to stop the timeline from playing before it turns off the light. Okay, so that's all it's doing here. So a sequence node, if you hover over, executes a series of pins in order. So this one is not like the flip-flop, which goes through one or the other, only each time it's called. This one will actually fire all of its execution pins one after the other. So it's going to do this first and then this next. Okay, so that's all fine and dandy. So we've kind of cracked that first one, hopefully. Does anyone have any questions at this stage on how the direct one-to-one blueprint communication works? No? All good? Excellent. If at any point I'm going too fast, please do interrupt. Remember to take notes, and we'll double back for questions at the end. Okay, so any holes in your notes, anything that you missed, do bring up. Okay, and I can see that you're following along there as we go through on the project yourself. Excellent. Okay. So just for reference, and how is this kind of a couple of how would you say this? So this one here is known as the working blueprint, because this is the one that references this one. Okay, and this one that's being referenced is called the target blueprint. Okay, so you can see here this person's name is target light, so we know that's the target. This one's the working blueprint because this is the one that's actually going to do all of the work, essentially. Okay, that's where the code is. So after direct referencing, we have what I like to think of as many-to-one communication. Okay, I'll explain that as we go along. So let's have a look at how this one works. This one, 1.1, which we've done. I just walk into it. There we go. This one here, just walk into it. There we go. Oh, looks exactly the same, or almost exactly the same. And we can see that this one actually rotates and lifts a battery, which connects with the bulb. So in this example, a light bulb blueprint is toggled on and off by connecting the battery. Okay, so that's different. The light bulb uses an overlap event to detect contact with the battery blueprint and turns on and off accordingly. So what does that mean? It means that the light bulb is actually using its overlap event. Okay, so it's checking to see when this battery touches it, and then it's executing its code. Okay, so that's a bit different to what's happening over there in 1.1. So let's have a look at this. So we've got the battery button, we've got the battery, and we've got the light bulb. Okay, and if we look in here, we can see each of these is a blueprint. Okay, something you may notice as well is anything you select inside the world that is a blueprint will have a edit blueprint here. So that's another way to get to it. So let's just have a quick look at the button first. Okay, button looks pretty much the same. We have trigger for the event, an overlap for the trigger collision. Okay, trigger collision there. We just go down, access that, takes us back here. Okay. But what we have here is we've got the flip-flop, we've got the changing of the material, but we have a new event here called move up down. And what we can see here is actually we're targeting the battery, okay, BP battery, and we're not targeting the light. Okay, so this object is communicating with this object. So this one is the, what's that one called? Working blueprint, and this one is called the excellent target blueprint. Okay, so not going directly to the light, we're coming to this battery. So let's open up this blueprint. Okay, so we can see that move up down event, which if we look back here, that's the one that's being called. We can double click to shortcut there. So what's happening this time? Okay, so we're trying to figure out a direction on a Boolean. Okay, let's have a quick look. So direction up, we can assume on this on, and direction down, we can assume on this off, and that's because when it collides, when the player collides with the trigger, this first one will run, and then this up down will run with a tick on it. Boolean on, so yes, it should. It's currently in the down state. On in the up state, I'll leave that collision. The flip flop fires again, goes off. Okay, so on, off. Again, it's very important to understand everything that's happening, so we know how to rebuild these things ourselves. So we have a branch here. So a branch statement basically checks if the condition is true. If it is, then this top pin fires or true, and if it's false, it will go down here. Okay. So can someone tell me actually what this branch will do to this movement timeline? Anyone want to take a guess?
It'll start the movement timeline to update your location and location.
Yeah. So how is this going to look in game here? We've got like a true and false. If this comes through true, what motion is going to happen?
Yeah. So when the person steps out of the hitbox, it's going to change the pulse and it's going to reverse the animation from where it is. That way it can jump to the end and then reverse back to it.
Yes.
Reverses from where it got to. It only plays from where it got to as well.
Excellent. Yes. So it actually starts playing this timeline. Okay, and we can see this timeline here. Starts at 0, and then by half a second should reach its kind of 1 unit. Oh, and we can see that it's basically looping, so doing a linear interpretation, though it does have a curve on it here, where it starts slow and winds up. What's really interesting about this one is this data is being used, and we can see out here, it's being used to look, okay, 25 units up, okay, 1 unit equal to 1 centimeter, so 25 centimeters up. That same motion is being used to rotate that 90 degrees, okay. So we're setting the relative location based on the lerp and the relative rotation based on that lerp as well. So you're reusing the same data. Pretty smart.
So the lerp's different from rotation and vector, or use the lerp and then over.
Sorry, could you repeat that?
So the lerp, it says vector and it says rotator. So would you have to search for them separately, or you just pull up the lerp and detect it?
Yes. So what we can do is we can pull off the thing here and search for lerp. And what you'll see is you've got the different ones. So we can select a rotator or we can select a vector. Good, yeah, so you'll call each one. What you might want to do is you could actually pull off here and say set relative location. And then you would select which one, and then you can pull back off here and get the same lerp. And then connect your movement lerp up that way. Okay, just going to fill this back in. Okay. So yes, as you said, what happens is it will play the animation and it will reverse the animation. Okay, so I can hop in and out, and if I do it quick enough, I can actually stop the battery from attaching. Okay, as long as I can get it within that 1 second that it needs. Okay, so how about the communication? Again, we've got direct communication, but it's with the battery and not the actor. So let's have a look and see what actually happens inside the bulb, because it says here the bulb uses an overlap event to connect with contact with the battery. So I can select the bulb and basically I can open its blueprint. Another way is I can right click, I can browse the asset, it will take me here, I can double click this inside the content browser. Third way for you to open up those blueprints. Okay, now this one, ooh, a bit scary. Lots of things on here, but if we take our time, we can understand them, especially since this person's been nice enough to put all of the steps inside comments. Okay, so just a quick check of the viewport is what I always do, just to make sure I understand the hierarchy setup. We've got the static mesh for the light bulb. We've also got the light itself. Okay, so the light source isn't the light bulb. This is an invisible object, say, which has a light color, and it will radiate that light out inside this area. Okay, so I'll just move that back. So basically they've put the light and the light bulb together so it makes a proper light. And then there's a connector trigger. Well, where's this? I'm going to use F on my keyboard to shortcut in. There's actually a small trigger box at the bottom of the light bulb. Okay, so I'll just move around a little bit so you can see. And they've lined that up with the where the battery would screw in. So that's pretty cool, though it's very, it's going to have to be very accurate. Okay, so it's only a very small zone that's checking for this contact. Okay, so I'm going to scroll down again. I'm just going to say, okay, let's have a look at the begin overlap. Okay, now there's a few things here. We've got the begin overlap, and I can see what the dynamic setup is. So this means like during play, when the trigger, sorry, the connector triggers or is sorry, when the connector trigger is overlapped or overlap ends, we're going to do something a little bit different this time. And here is our many to one. So this is our cast to blueprint battery. Okay, so what it's doing is with this event begin overlap, it's actually going to check the other actor. So I'm just going to move this out a bit so we can try and see it a bit better. It's going to check the other actor. So this begin overlap actually carries all of this data with it. It tells us which component's been overlapped, which actor is the other thing that's overlapping it. We've got kind of sweep hit results and things like that. So I'm going to pull off here, and actually we can, let's see, I'm just going to print, I'm a print string, which you guys have used before. I'm going to append, just to make a nice little message for myself. Other actor equals, and I'm just going to plug this in to convert its reference to a string so I can get the name of it. Okay, I'm just going to connect this in between here. So it's actually just going to print out for me so we can see. And this is something I use all the time just so we can see what data is coming through. It is a very basic way to do it. There's more advanced ways to do it with watchers, watching the value, but we'll not get into that at this stage. Okay, so all I've done here is I've modified it so I can see what the name of the thing is when it comes through. Okay, so I'm just going to compile that. I'm going to hit play. Actually, I'm going to hit this one here and do new editor window. Of course, it's open on my second window here. And also got the debug filter on. And let's just let this debug in real time. Okay, and we see the execution fire. Okay, and the other actor it's telling me is a blueprint battery. Okay, the reason I've done this is to show you what happens. Okay, now the cast, this is, you can kind of think of this like a branch. Okay, some kind of gate. What it's going to do is it's basically going to check, is this object that's coming through, is it one of these types of blueprints? Okay, so is it a BP battery? If it is, then this top execution node will fire. Okay, success. And if not, it will fail. Okay, now if it fails, you can actually hook up some logic so you can do something else with it. But a lot of times you'll see them disconnected like this. That just means do nothing. Okay, so the rest of this chain won't fire because this one only fires if it is a matching blueprint. This object matches this blueprint. Okay, so that's your cast node. This object reference had me stumped for so long, coming in as a designer in 2014, not knowing too much about Unreal or programming. I didn't understand that. But basically, your object reference is a reference to the same type of blueprint. If it isn't the same, it will not fire. Okay, you'll get cast failed. So what I tend to do is actually, because I still consider myself a noob, I will print string something like cast to BP battery. Okay, so this one failed in, and then I'll get the name of the blueprint. Okay, BP light, whatever. And then that will help me in with my debugging. Okay, but as you saw before, actually, if you have this blueprint up in the background and the drop down is here for the selected blueprint, which is whichever one selected inside the viewport in the level, we will get the strings firing in the background there. Okay, execution across the back. Okay, so what does this cast do then? So basically, the way I imagine this is that you are taking remote control of whatever object you've casted to. Okay, so just as before with the direct reference, I can actually pull off, and this is a little different. Instead of just pulling off kind of a variable, I'm pulling off this here, and I can access all of the values and functions inside that blueprint. Okay, so let's bring up the blueprint battery just for a second there. Let's do this one where I click here, I right click, browse to asset, double click, and I'm going to bring it up on this side. So let's have a look. Oh, that's me. Nope, that's me again. Oh, it's because I've got both of them like this. I'm just going to put this one on the left side here, this one on the right side. Okay, so anything I pull up here, I can access, say, the move up, move down. I can access the electricity value, the mesh. I can access all these components, and I can do things to their settings, to the settings being the things inside their details panel. Okay, so that's what we're seeing there. Shrink that one down. So what's actually happening with this? Okay, let's move this just back here. Zoom in. We can see that as the battery, we're getting the retrieving the value of the float. Okay, so we're retrieving some data. We are also reading the value of the electricity supplied by this battery, okay, which is local variable. And we're adding the two together, okay. And then we are setting that same value that we just retrieved to the new value, which is this combined, okay. So we're adding battery value to the light bulb's value. Okay, so that's cool. So it's taken the energy inside this battery the charge, say the number, and it's setting it inside the light bulb. And then we are playing the toggle light, which is inside custom event, which is inside here. It's not actually inside the light bulb. What it's saying is I'm going to branch, we're going to do the light flash, update color, etc. Okay. So this one's a bit more complicated, but if you dissect it slowly, you'll be able to figure it out. Now you might wonder, why is this initial setup here? This is just simply because when play begins, what we want to do is something a bit different. Okay, so we're actually going to check just in case the level designer has any of these objects already overlapping. Okay, so say for example, as a level designer, accidentally left one of these right there. What we want to do is be able to have this blueprint safely check to see it when it starts for each connector trigger. Okay, these ones here. We want to check and see, check if they're batteries, and then again do the same calculation that we're doing here, which is basically add the supplied electricity and toggle on the light on. Okay. At the end here, we'll see that toggle light actually has a condition where this will run only if A is greater than B. So if the electricity supplied is greater than 0. Okay. All right. Sorry, 1 second. Okay, so I made quite a mess in here with my print strings and dragging things about. Just a quick tip, there's actually ability to use Control-Z to go backwards, but you can actually view the history here. If I open this up, the undo history, which will show me all of the things to undo. So I'm just going to stick this on the left and this on the right so we can see this in real time. If I hit Control-Z, we can see that it's going back through this history of all of the things I've done, everything like clicking on actors, moving actors. I can keep pressing and we see the output on the left, and on the right we can see how that works. Now I can actually just jump back to a specific location by jumping to this transaction. Oh, that's nice. That's sorted out. Oh, actually, I went too far back. Let's just do this one. Okay, so I can move backwards and forwards. I can also delete this history out if I'm a maniac and I trust myself entirely, but I generally do not do that. Okay. So we have looked at one-to-one communication and many-to-one communication using cast blueprints. Now, you still might wonder, what does he mean by many-to-one? Okay, what I mean by many-to-one is that casting is very easy to get out of control. Okay, it's very easy to use casting, overuse casting, and end up with a bloated project where a lot of things are being loaded that don't need to be. I'll just try and explain this a bit further. So what I'm going to do is I'm going to duplicate this battery. Okay, so I'm just going to Alt drag out. I can also press Control W to get duplicate. I'm just going to connect a few of these batteries actually to this, and we'll see what the outcome is. So I'm just going to rotate. I'm going to move this up as well. Will this connect? It should do, I think. Okay, let's hit play and see what we've got. Oh, only one moved. Why is that?
Because the buttons only connect to one of the battery components.
Excellent, yes. The button is still using one-to-one communication, direct communication with that battery. Okay, so let's do something fun here. Let's drag out another button and another button. I'm just going to move them a little closer actually, so we get some good overlaps. And how do I get these buttons inside here to actually hook up with these batteries?
Would you go with the blueprint and change the cast to the automatic?
Would I hook up the blueprint to cast to the other battery? I wouldn't hook up the blueprint to cast to the other battery. There is a kind of a direct method that we're using already that I can edit from inside of this screen.
I change the value to the different batteries.
Yes, how am I going to change the variable from this screen to the different batteries? Not in the world outline on the top right. The details panel, yes. We'll see here the target battery. Okay, the target battery so far is set to this one. So if I hit play, they are all referencing that one battery. But I want to select, say, this one and connect it to this one. I can use the eyedropper, and I've got battery 2. Again, use the eyedropper. Battery 3. And now I should have, this is a fun thing I like to do. Let's guess what's going to happen. What should I have if I've done this right? When I overlap the first button here on the left, what should happen?
I think the battery will go
Left battery?
upwards and turn.
Okay. Oh, upwards and turn. Not. We'll see. Okay, so let's try and just interact with that first one. I'll edge a little closer. Oh, it moved in the correct direction because it's taken that information from its local rotation. But we didn't actually move it far enough in. We get 2 if we overlap the 2. And I can move that one. So let's just have some fun here. Again, just experiment. Let's bring this a little bit in. Let's bring that one a little bit in. Let's see if we can get back there. Can we get 1? Nope. 2, 3. Too high? Okay, so let's change our movement size here. And let's hit play. Come on, gotta get this. So this is the problem with the very small thing here, is that it has to be very, very correct when it overlaps. Let's see if we can get that. Now I was just eyeballing that, so I wasn't very particularly paying attention to where they were going. Okay, so now what happens actually when I overlap multiple of these? Yeah, so actually we've got multiple ones affecting this. So many blueprints here are communicating with that one. You can see that actually the bulb gets brighter because, because it is essentially, okay, so it's getting brighter again, because it's essentially given that charge through the blueprint. All of that code is running, and it's having a cumulative effect. Okay. There you go. Now let's have some fun again. Let's just see if we can cause some havoc. Each of these objects in the level, okay, has a variable for the battery mesh, okay, but it's also got an electricity value, okay. So this is an exposed value. If I edit the blueprint, we can say, actually, the battery mesh is exposed and the electricity value is exposed. Wait a minute, what is this? This one's green and this one's yellow. Do we ignore that, or do we figure out what that's for? So if I hover over here, I can see it says variable is public and is editable on each instance of the blueprint. We've seen that one before, we understand that. This one, I hover over, it says exactly the same. Why is that?
Because it does the same thing, it's just a different variable.
No, unfortunately not. Good guess though. So this one, it has a description called a static mesh piece of geometry, yada, yada, yada. This one actually has a custom description. Okay, so this, by default, if I create a new type of variable, switch it to a float, its tooltip is empty, and it picks the original tooltip for Unreal, which is basically just hold Control Alt for more. There's nothing really there. It just tells me that it's a float. I'll just delete that out. Oh. Now this one actually has one that says value representing the power of the battery. If I click on this, we can see that someone set a custom tooltip, which is very handy and tells us what this is for. Okay, if I deleted this out, hit enter, hover over, we get the thing that we had before, which is the float. I'll just Control Z that. battery mesh, it's picking up the Unreal basic. If I stick some gibberish in there, it will pick up our gibberish instead. Okay. Okay. There's Control Z in there to get back to where I was. Right. Got a little bit distracted there. Electricity value. So yes, electricity value is inside the blueprint, and electricity value here is by default 10. Okay. If I change this value, it will change the value, because this is the blueprint that governs all these batteries in here. It will change the value of all of these inside here, okay, to a different number. But if I just want one of the batteries to be, say, like a supercell, okay, say this one here, and I want us to do 1000, okay, then I can select it inside of the viewport and edit it here. And what's nice is these are all instances of that same blueprint, and they're individually editable. So you'll notice that they have different values. So this one could have a value of 250. Okay, think of this as like ways to edit individual objects. Okay, say if you've got 5 rocks that destroy after so much damage, you might expose the amount of health they have, like how much damage it can take, to be different values based on different things. Okay, so this rock's got 100 health, this one's got 250, etc. Enemies might have different values for their health, they might have different values for their attack power, and you can individually tune these inside the designer without having to go into the blueprint and change all of them at once. Okay, let's just head back over here. So we've got our what is now a weak battery. See if we can trigger the mega battery. Yep. And then the mega battery plus the pretty strong battery. Okay, we're going to see how that's cumulative. Okay, so fun with batteries. So we've got these other 2 to go. These ones are blueprint communication via actor casting to child blueprints. So we've just had some fun there and made 3 actually. Let's have a look and see how these work. So if we go over here, these light bulbs are turned on off by connecting different types of batteries. Each battery is derived from the same parent blueprint, but has a different energy value that affects the brightness of the light. Okay, so what does it mean that they have they're derived from the same parent blueprint?
It means if you're to affect the parent blueprint, it will affect all the child blueprints.
Yes, so if I affect the parent blueprint, it could affect all the children blueprints.
So
Yep.
Child blueprint inherits all of its physics and right word. All the physics and all the variables from its parent, and then you can edit it from there at different values.
Yeah, so we can have basically a parent, which is like a set template for each of these ones underneath. So it can have a set template where it has values for different things. So let's have a quick look. We've got BP battery. Excellent. We've got a small battery, a medium battery, and a large battery. Okay, so let's just open these up. I'm just going to select all of them, and then I'm going to click edit BP battery. Haha, didn't work. So I'll just select one at a time. Edit multiple assets. There we go. Okay, so this is weird. The battery is the same battery from before that we've dealt with. This big child and small child don't look the same. We'll notice that it's got a bunch of stuff that appears inside of the details panel for the class defaults. Okay, so there's class settings, class defaults, and that's for the overall blueprint instead of the individual items within. We can see that the class defaults are here, and we've got 25 for this battery and 4 for the small. Excuse me. And we can see that the parent class is BP battery on all of these. Okay, apart from this one is actor. Okay, so this one is the parent. These 2 are the children. Okay, so this is the default battery, and these 2 are 2 edited batteries. Okay, and we can say jump back to that blueprint battery by opening that in editor, and we can see that it has electricity value, battery mesh value. Okay, which we've seen before. It's got its connection trigger, its battery. But this, where is all that? Anyone know how to access that? Excellent. Open full blueprint editor. Aha. Now it looks the same. Okay, so that's something to keep in mind. If I want to view everything inside of here, okay, including all of the things from the parent, I would do that. Now I've got the battery, and basically it's being adjusted to have a high electricity value, and it's being given a different mesh, okay, because this mesh, again, is a variable. It can take multiple different types of mesh. You can even set it as something completely different. Okay. And we see here the construction script, which is usually here, which has this stuff here, just says, hey, just take the stuff from the parent's construction script. Excellent, we don't have to fill that out again. In the event graph, wait a minute. Nothing? What's happening here?
It's only all it's been inherited through the pieces.
All of the event graphs already end up inherited, so it doesn't need to be duplicated to the child.
Yes, so all of this does not need to be duplicated to the child, otherwise we'll end up with big mess if we start adjusting all of these individual ones. Okay, so we can see here that there's a bunch of things inherited, and there's reference to the construction script. Nothing inside here though. The variables look as though they're missing, but we need to remember that anything that is a child is the same as the parent. What do I mean by this? Time for a little Microsoft Paint, my favorite program. Prepare for some next level art here. Okay, so we have a parent, okay, and we have some children. Okay, we might have another type of blueprint which has a child as well. So let's say that this is a light. And this is, sorry, let's use the example inside there. So this is a battery. And this is the small battery and the large battery. Let's say this is the light. And this is the disco light. Okay, so how the inheritance is working here is the small battery is also a battery. The large battery is also a battery, but they are not the same thing together. Okay, so a large battery is not a small battery. So an inheritance is a chain of parents and children. This light is a light. The disco light is a disco light, but it's also a light. Okay, so a light and a battery are not the same thing, and these children are not the same things either. But these two children on the left do inherit from that battery. Okay. So why do we bring this up? Because we've got here a situation where these things are using a communication to reference the child blueprints. Okay, so we can see here this one has a target of this battery small. This one has a target of the regular battery, and this one has a target of the battery. Now, if I move along here, I can see that each one basically connects to each one. So I wonder, what if I take this large battery and stick its connector right there on top of the other one? Can I get it to trigger? What should be the outcome here when I press the button on the right?
The battery will go like this, that light is casting of that battery.
Excellent, yes. So the light, we suspect, is not cast into this battery to check, because it's actually wanting to check for a different type of battery. Okay, so the one in the middle, that's the medium battery, will still work. One on the right. Oh, wait a minute, what's happened?
The one on the right is cast into the middle battery and move the data in and not the right battery.
Oh, it's because the batteries all have, the lights all have the same blueprint, and they just pass to the parent blueprint battery. It doesn't pick whether it's a child blueprint.
Okay, let's have a look and see which of you is right. So here we're looking at the light now. We've got the cast to blueprint battery. Okay, so whatever comes through, if it's a blueprint battery, it will function. Okay, interesting. So why does the large battery and the regular battery both activate this light?
Because they're both connected batteries.
Yes, because they are both batteries. Remember the inheritance before? They are both batteries, okay? So these small batteries are still classed as batteries. They are individual types of batteries, but they're also batteries. Let's move this one across here and just check this light here and see what this is checking for. Cast to blueprint battery. So what should happen here with these as well?
Turn on.
Both turn on. Turn on. Turn on. Okay. Now let's say I only want this, this light, I only want this one to be activated by this battery. What would I have to do to this light to basically restrict it from being powered by any other power source?
You'd have to cast it to that specific battery.
Yes, I would have to actually ask this to cast to this specific battery type. So the check will only run true if it is that type of battery. Okay. Check my notes. Okay, so let's try editing the battery here. Quick little tip. This is experimental, but I will show it anyway. I'm going to go to Editor Preferences. What I want to do is I want to start editing this, but unlike before, I don't want to make a massive mess. So what I want to do is I actually just want to disable nodes. What I've done is I've went to my Editor Preferences there, Editor Preferences, got this window up. I've typed in disable across the top to shortcut everything that includes disable. I'm going to general keyboard shortcuts. By default, this will have nothing in. I click in the thing and I'm going to hit Alt Enter. And what this is going to do is it's going to allow me to disable nodes. Okay. So what I can now do is I can right click and I can see that there isn't any type of way to disable this. So just stop this from running. I can now hit Alt Enter with this and can actually just disable that node. The reason I'm going to do that is because I'm going to actually disconnect it, but I don't want this cast causing any problems when I compile. Okay, so I'm just going to come up here, cast to battery big, yeah, and it's big child. So only now, if this other actor, and I connect that up because it needs to be there. If I do not, so let's break that, I'll get an error. It's unconnected, it will always fail. Oops. I'm going to lift this, connect it here, so we'll check, is this other actor a large battery? Okay. If it is, then we're going to continue on with the function here. Something I've got to be careful though is I'll also need to connect this up here because I need the electricity value of this big battery, not this one, that's all. Okay, so that's just disabled for now. Okie dokie, let's see what happens now. Okay, small battery? Nope. Medium battery? Nope. Large battery? Aha. Okay, so in this, what have we learned? If we cast to the parent, all three will activate on the light. If I cast to the child, then I only get the one that is of that type. Okay? Like I said, this can be super confusing the first time. So if you have any questions now about casting,
It's like you're casting multiple things. So now I wanted it the medium battery and the large battery and turn it on, but not the small battery because it was a high powered light. So could you cast for multiple?
Yes, you can cast multiple, but for reasons I'll go over in a second, we actually want to try and avoid casting when we don't need to do it. Okay? But yes, it is possible to cast to one thing and then cast to another thing, any object. As long as you're getting references along the way, you'll be fine. But remember, you should cast to something to check, kind of access its capabilities. Okay. Okay. Okay, the next one I'm going to show here is this one, and this should finally explain, well, kind of, as I do this, I'm going to finally explain the difference between, kind of in my thinking that casting should be many to one, okay, if that should make sense in the end. So, in 1.4, end of the level, we can see that this setup is actually very simple. The collection of light bulb blueprints are all turned on and off by one button. The button blueprint finds all instances of the light bulb class and casts the toggle light custom event in each of them. Okay. Now, this setup you're going to see and be like, oh, that's pretty cool. That's nice and simple. Let's do that every time. Do not do this. Okay, so I'm looking at the button. Okay, first of all, we can see actually when I select this, there isn't a direct reference that I need. Okay, again, flip-flopping, setting the value of the material, but wait a minute, what are we doing here? What's this thing? Instead of getting a reference, a direct reference to light, what we're doing is we're going to get all actors a class. Okay, now that gets an array of all the actors in the level. Okay, the level being anything that's inside of the world outliner when the game starts, anything that's inside this viewport, and for each of those, for each item in the array, okay, in the list, so collecting all the actors together into a list, into an array, and for each of those, we're going to go through and we're going to check to see if that object is a BP light bulb pulse. If it is, then we're going to use the toggle light on it. Okay, so we're going to fire its toggle light event. Turn it on, turn it off on the second, on the B track. Okay. So what's happening is at runtime, this thing, when we collide with it, this is sending out a message to the engine, right? All of the lights, all of these types of lights inside the level. Okay, so I'll just duplicate loads and loads out. Okay, all of these lights, we're just going to collect them into a big list and we're going to turn them all on. Okay, can anyone guess as to what the problem is with this method?
If you have a light anywhere else, always get down.
Yeah, so all of them are going to pulse everywhere across the whole level. What could be a problem with this method of just collecting everything?
If you're using a button to open a door, somebody will find a way to press the button long enough to get to the next area without doing whatever they need to do the next one.
Yeah, that's a possibility depending on your level design. Let's have a look at what the tooltip actually says here for get all actors of class. Finds all actors in the world of the specified class. This is a slow operation. Use with caution. E.g., do not use every frame. Okay. So get all actors of class is actually a slow way to just get everything inside the level. So in a single frame, the engine's gonna have to query everything inside that world outliner list and basically collect them all up. Okay, we have selected like a filter that we're only looking for this type of object, but it's still a slow operation. Okay, and yeah, there's problems in terms of design about turning all the lights off, opening all the doors. You don't necessarily want to do that sometimes. Okay. So if we had to do this and do a for each loop on every single frame when this is done, then that's a problem. Okay. So what's a way that we could use what we already know to avoid having to get all actors of class? Well,
You could use a parent blueprint for all of them.
we could use a parent blueprint for all of them. Well, we're trying to avoid this node here, this get all actors of class.
So we just make a parent blueprint for all of them. So when you lock parent first, it activates and sticks out child blueprints.
I think I know what you mean. So you're saying that we create a parent blueprint and then we create lots of children blueprints. We put the children into the level,
Yeah.
and then actually we reference the parent and tell it to turn all the children on. Okay. Unfortunately, that's not going to work because the parent, just because there's a blueprint made of the parent, if it's not on the level, it's not going to get activated. Okay. And if you reference the parent, it doesn't necessarily mean that the children are going to receive that input, that event either. Okay. Okay. So let's see what we can do. We could use a combination of what we've already got. Okay. So we can use the direct referencing, 1-to-1. We can use casting many to 1. Okay, there's actually some other cool features here. So I was just checking to see if you had came across them before inside the engine, which we'll get into in this room. Okay, which is event dispatchers. Okay, which kind of solves that problem for us. There's also blueprint interfaces, which we could look to use, which we'll examine in the third room. Okay, so let's just have a quick check. Why we don't want to kind of just reference things and cast in and get all that as a class willy-nilly. I just want to go back to where I talked about the many to 1. Okay, now if we cast too many times or we cast the wrong way, we end up with a lot of performance issues. Okay, now these batteries are casting to these lights. Sorry, these lights are casting to the batteries. That's not such a big deal. It's not terrible. But imagine we were casting, say, to the character. Okay, we can cast to a character and we can ask, like, kind of control something on the character, get some values from the character. But if we were the character and we were casting out to other objects in the scene, then we would have a problem. So I'm trying to think of the best way to describe this. Basically, whenever you cast, okay, whenever you say that cast node, what it will load, it doesn't just load the blueprint that you're talking about. So say this, let's have a look and see if we've got one here. Do we have the character's blueprint? Blueprint, yeah, player character. So say we're casting a player character. When we cast to this character, we're not just loading up all of this information here, all of these objects, okay, inside here, all the character meshes, all the variables, all of this code. We're also going to load into memory everything that this blueprint is referencing. So we can see that there's a camera that it's referencing, there's kind of materials, meshes, and other things that it is referencing. We can actually right-click here and we can use the reference viewer to see all of the things that it's referencing. Okay, so this is quite interesting. In the middle, we've got the player character. Everything to the right is what it's referencing. So all these things are going to get loaded into memory. Okay. To the left is anything that references it. Okay, so we can see the levels and the game modes here are referencing the player. That's not so bad because basically if the level's loaded, the player's going to be loaded. Yeah. Now, let's have a look. If we cast to this player character from a light or something like that to say get some value from the player character, it's also going to load all these things. Now let's just have a look. If we search the depth limit and increase this, okay, we actually get to see how complicated this becomes. Okay, so the depth of 2. Now, this if we cast the character, we're also going to load the blueprint slider, the button, physics reactions, standard macros. But they also reference other things as well. Okay, so now they have to load all of these things into memory. And if we increase this, we'll quickly see how this can get out of control. Okay, so everything right of the character, when we cast the character, is going to be loaded. Okay, so 3 layers deep, 4 layers deep, etc. Okay, so what you can end up with is a massive amount of memory being loaded just because you cast it to a specific blueprint. Okay, now if you've set up your, say, your light to cast to an enemy, okay, and you cast to that light as the player. So I cast to the light as the player, thinking, hey, I just want to turn this light on and off. Okay, but inside the blueprint for the light, it's cast into an enemy because it's doing something else. It's going to load up that whole chain of everything that references as well. And if the enemy references more things, it's going to load up all of those things as well. Okay, so quickly gets out of hand. So this is why it's best to avoid casting unless you are doing it in a specific way. Okay, so it's not evil. It's just very easy to get it wrong. Easy to kind of bloat your project. So I'm just going to click this again, and instead of the reference view, I'm going to use the size map just to show you visually how this works. So here actually is the blueprint. We're using 504.7 kilobytes just for the blueprint itself, but actually the character is loading 30 total assets. Okay, all of these objects here, as I mouse over them, they're all being loaded into memory as well. So we can see all the things that was mentioned before. Okay. And what you can do is you can actually click into these, and you can see that as we go back, all of these things are loaded, all of these things are loaded, all of these things. Okay. So just to show that again. You can drill down to each individual thing. So there's a 13 kilobyte texture. These are all loaded. They come with that. All these things loaded. They come with that. Okay. Some of these get very, very big. If we look at something like a level, okay, so if we look at a map and we look at the, so say the blueprint communication level that we're on, and we look at the reference viewer, we can see all those things are loaded. If I increase this number, all these things get loaded into memory. Okay. And then if I look at the size map, what does that work out as? Well, that one level, 3.5 megabytes, 204 assets total. And you can see kind of how quickly this gets out of control. Okay. So when you cast in, all of this information is being loaded if it's referenced by a blueprint. Okay. So just to recap, basically casting loads the referenced class, the thing that you're asking to load, plus the hierarchy, everything inside of that blueprint, and all of the things that references. Okay. So for situation dependent functionality that's occasionally present, for example, a button. Okay. Casting to core functionality that's always present, for example, a player, is okay, but we don't want to do it the opposite way around. Okay. We don't want the player casting out to things that are kind of just there situationally, because then they start loading their chains of references. Okay. Basically, the player, if you think about it, the player is probably always in memory, so it's okay to cast into the player. Okay, but try not to cast out of the player to things that are like not necessarily needed in memory. Okay. Tomorrow we'll cover the dispatchers and the blueprint interfaces. And yes, let's break for lunch.